Good day. We'll discuss areas under the normal curve applications to word problems. Recall that this is our table for the standard normal distribution. So problem number 1. The average salary or pag-ibig salary loan for RFS Pharmacy Incorporated employees is 23,000 pesos. So meaning this is our population mean. If the debt is normally distributed with a standard deviation of 2.5, so this is the population standard deviation, find the probability that the employee owes less than 18,500. So we will use first a random variable x, so less than 18,500. Okay, and then we will convert this one into a z distribution using the formula z is equal to x minus mu over the standard deviation. Okay, so this will become p of z less than, we will substitute the given, this one, 18,500, which is our x here, minus our population mean, which is 23,000, and we will divide this by 2,500. So using your calculator, you may use your calculator in solving this one, divided by 2,500. So we have negative 1.8. So this is therefore z less than negative 1.80. Okay, so if we draw this one on a normal curve, this is now our 0, and negative 180 is on the left side. Okay, so meaning this is the area that we'll be needing. Okay, we will need this area. This is now the probability that the employee owes less than, so to the left of negative 1.8. So the strategy here, since it is to the left, we will use the strategy 1, which is we will use directly the value on the table. So direct, so negative 1.8 on this side, negative 1.80. So we have it here. So we have 3593, 0.03593. So this is equal to 0.03593. So again, negative 1.8 is here, then 0.03593. So this is the 0 column. Okay, so we have it here, 0.03593. So the probability that the employee owes less than 18,500 is 0.03593. Next, the average age of bank managers is 40 years. So this is our mu, population mean. Assume that the variable is normally distributed. If the standard deviation is 5, so this is our population standard deviation, find the probability that the age of a randomly selected bank manager will be in the range between 35 and 46. So between, so x is in the middle, or is at the middle. So between 35 and 46. So again, we will convert these two values to the standard normal distribution, or z-score. So this will become 35 minus the population mean, which is 40, divided by the standard deviation 5. And the other one is 46 minus 40 divided by the standard deviation 5. Okay, and you may use your calculator to solve for this one, para sure. So obviously this is negative 5 over 5 is negative 1. So z so we have on the other side we have 6 divided by 5, that is 1.2. Okay, so if we draw the normal curve, -1 is here and 1.2 is on the right at the right side of 0, so we will be needing this area. Okay, so the strategy here is to subtract the area, no? So the bigger area is the one which is farther from the left, so this one, 1.2 minus the probability of z less than -1, or simply you'll just cross the areas, no, from the table. So 1.2, what is 1.2? Positive 1.2. Okay, we have here 88493. So 0.88493 minus, what is -1? Okay, 15866. 0.15866. Let me check it again. 866. Okay, and then using your calculator, you subtract these two. 493 minus 0.15866. So the final answer is 0.72627. So therefore, the probability that the age of a randomly selected bank manager in the range 35 to 46 is 0.72627. Next, a company produces the different types of energy drinks. The filling machines are adjusted to pour 500 ml of energy drinks into each plastic bottle. Nonetheless, the actual amount of energy drink poured into each bottle is not exactly 500 ml. It varies from bottle to bottle. It has been observed that the amount of energy drink is normally distributed with a mean of 500 ml. So this is our population mean and our standard deviation of 4.75 ml. What percentage of the energy drink bottles contains 505 to 530 ml? So of course we are asked to find the percentage. So first we'll first compute for the probability. Okay, from 505 to 513. Okay, same with the previous example. So we'll compute this using the formula that we had. So 505 minus 500, which is the population mean, divided by the population standard deviation of 4.75. And we have now the z-score. We have here 513 minus 500 over 4.75. So please use your calculator. So this is 505 minus 500, that is 5 divided by 4.75. So we have 1.05. Okay, so up to 2 decimal places only, round off to 2 decimal places. And on the other side, we have 513 minus 500 is 13 divided by 475, 2.74. Okay, so again, as a shortcut, we can cross this, the area of the larger one minus the area of the smaller one. So the area of 2.74, okay, this is 2.7, 4 is here, so 2.74 is here, 99693. 99693. 99693. And the other one is 1.05. Again, it's also positive, so let's look at here, and then 5 is here. So we have here 85314. 0.85314. So you subtract. So 0.99693 minus 0.85314. So we have 1438. I will just write the 5 decimal answer. So 0.14379. So the percentage, we're asking for the percentage, so we'll just multiply it by 100%. So times 100%. So the answer now is 14.379%. So 14.379 of the energy drink bottles contain 505 to 513 ml. Okay. Next example. Consider the investment stock market whose return is normally distributed with a mean of 20%. So this is our mean and a standard deviation of 8%. Determine the probability of earning money. Of course, when we talk about earning money, it must be greater than 0. Okay. So basically, we'll just convert this. So we have 0 minus, okay, we'll just do not mind the percentage symbol, so we can use actually 20 and 8 because we can just cancel the percentage. So we have negative 20 divided by 8. So we have negative 2.5. So Z is greater than negative 2.50. Okay, so this is greater than. So if we look at the drawing, so negative 250 is here. So we need this area. So our strategy here, remember, is just 1 minus probability to the left of the negative 2.50. Okay, less than or equal, they will have the same value. Negative 2.50. So negative 2.50, we have here 0.00621. 0.00621. So if we operate this one, we'll have 99379. 0.99379. So the probability of earning money is 0.99379. Next, the average daily jail population in the New Bilibid prison in Muntinlupa City is 36,295. So this is our population mean. If the distribution is normal and the standard deviation is 3760, so this is now our population standard deviation, find the probability that on a randomly selected day, the jail population is greater than 40,145. So we're asked to find the probability that the jail population is greater than 40,145. So again, we'll have this. We'll convert this one to the Z, to our Z score. So we have 4145 minus the mean 36295 divided by 3,760. So you may use your calculator. 4145 minus 36295 divided by 3760. So we have 1.02. So positive 1.02, and it is greater than So again, the same with the other previous example. So this will become 1 minus the probability to the left of 1.02. Okay, so this is 0. So the area to the left of 1.02, so positive 1, 0, 2 is here. So we have 84614. 84614. So again, 84614. So we subtract this from 1 minus 0.84614, 1386.1386. So if we draw this one, it's positive. So we have this and greater than, so to the right. So this is our area. So the probability, therefore, that on a selected day or randomly selected day, the jail population is greater than 40,145 is very small, 0.1386. Okay, and last example, I think, second to the last example. The average credit card debt for a public school teacher is 14,975. So this is our population mean. If the debt is normally distributed with standard deviation of 5,650, find the probabilities that the teacher owes, letter A, at least. So when we say at least, the smallest is 6,740. Okay, so that is greater than or equal because it uses the words at least. Or is that one word? So at least 6,740. So this is now z greater than or equal to 6,740 minus 14,975 divided by 5,650. So again, use your calculator. 6,740 minus 14,975 divided by 5,650. So the answer is negative 1.46. Greater than or equal to negative 1.46. Okay, so if we draw this one, again, this is greater than, so negative 1. Somewhere here, negative 1.46. So greater than, so we'll be needing this area. So this is now 1 minus, what is the value? Greater than. So this will become 1 minus the area to the left of negative 1.46. So using the table, negative 1.46, negative 1.4, 6 is here. So we have here 7215, 07215, 07215. So we have 1 minus 0.07215, 92785. So the answer is 0.92785. So the probability that a teacher owes at least 6,740 is 0.92785. And last, find the probabilities that the teacher owes more than 19 to 70. So again, this is more than. So the same with the previous example. More than is greater than 19 to 70. So this is now z greater than 19 to 70. convert. So minus 14,975 divided by 5,650. Okay, so this is now, what is this calculator? 19270 minus 14,975 divided by 5,650. So this is equal to 0.76. So again, this is greater than. So pag greater than, we'll just take the 1 minus the area to the left. Because again, our table is the area to the left. So 0.76 positive, 0.7, and then 6 is here. 77637. 77637. So 1 minus 0.77637. 223. So we have 0.22363. So the probability that a teacher owes more than 19,270 is 0.22363.